Solving exponential equations. So we're going to learn to solve exponential equations by using the method of finding common bases. Okay, so we're always going to get the same base on both sides of the equals. So to solve an exponential equation, we need to find the value of the variable that makes the equation true. The reason that an equation like this would be called an exponential equation is because x is in the exponent. Okay, versus like this, it's just a normal linear equation because x is not in the exponent, versus 2 to the power of x equals 16 is an exponential equation. Okay, so this is what we're focusing on, and the reason it's called an exponential equation is because the x is in the exponent. Okay, so this common basis strategy says that your first step is going to be to rewrite 16 with the same base as your exponent. So my exponent of x has the base 2, so I want to write 16 as 2 to the something. So you're going to have to play with your calculator, and this is where it can get frustrating. We know we want it to be 2 to the something. We know it's not 2 squared, so you might be like 2 to the power of 3, that's only 8. 2 to the power of 4, got it. So I can rewrite 16 as 2 to the power of 4. So what we've done is we've created this really easy equation to solve, because what we're asking ourselves is what power do we put x to get 2 to the power of 4? So 2 to the what is 2 to the 4? Well, obviously, x has to be 4. Okay? 2 to what power gives me 2 to the power of 4? 2 to what power gives me 2 to the power of 4? 4. Okay, so x equals 4. So that's our strategy. Let's try it out. So 5 to the x equals 125. So the strategy of common basis says I'm going to keep the left side the same, and I'm going to rewrite 125 as 5 to some power. So I have to figure that out. So I might try 5 squared. 5 to the power of 2, 25. 5 to the power of 3, 125. So I can rewrite 125 as 5 to the power of 3. And exponential equations. The only way this equality can hold if the bases are the same is if the exponents are also the same. So at this point I put a little therefore, x has to equal 3. If the bases are the same, the only way the equal sign holds is if the exponents are also the same. So once you get the bases both the same, these have to be equal. Okay? Otherwise, it's not an equation. Okay? All right? Now we're getting a little bit harder. So in order to write both sides with the same base, I don't want 1 over 9, because I want my number in the numerator. Okay? So my first step would be to know that I can rewrite 1/9 as 9 to the power of -1. Is that true? It is 1/9 equal to 9 to the -1. Let's take this back to what we just did. Okay, so, or you can think about it as, if I want to bring the 9 up to the numerator, I have to change its exponent from +1 to -1. You see that way of thinking of it? Okay. All right. So we're still not there yet. Now, ignoring the -1, is there a way to write 9 as 3 to the something? Is there a way to write 9 as 3 to the something? Gary says 3 to the power of 2. Does everyone agree with that? Okay, so I'm just rewriting the 9 now as 3 to the power of 2. But that's all to the power of -1. So I replaced 9 with 3 to the 2, but that was still to the power of -1. And what does the rule say when I have a power to an exponent? You keep the base 3, and multiply the two exponents. So 2 times -1, -2. So I finally got it into that place where 3 to the x equals 3 to the -2. So I've got the exact same base on both sides, which means the exponents have to equal each other. So therefore, x would have to equal -2. Okay, and some people can do these in their head, which is great because then you'll know your answer's right, but what I want you to do is show the algebra, because tomorrow when they get harder and you can't do them in your head, you need to know how the strategies for getting to the answer. All right, so knowing that, base C. Okay, so as I walked around, I saw lots of people's first step was this. How many people did that for their first step? Excellent. Okay. Second step should have been to rewrite 64 as 4 to the third. But that's still to the -1. Okay? First step, second step. Third step is to, on the right side, keep the base and multiply the exponents. So you've got the exact same base on both sides, simplified as much as you can. And then we're ready, got the same base on both sides, so therefore x would equal -3. Does that make sense? Okay. Next one. 4 to the power of x equals 32. This is a good one. This is where we have to get a common, smaller base. A common, smaller base. Because if you tried to write 32 as 4 to the something, you would do 4 to the power of 2 is 16. 4 to the power of 3 is 64. I can't get 32 using whole numbers. Okay? So then what you want to do is see, can I rewrite 4 and 32 with a smaller common base? What would that smaller common base be? 2. Okay, so I can rewrite 4 as 2 to the power of 2, but that's still being put to the power of x. So I can rewrite 4 as 2 to the power of 2, but that's still to the power of x. And I can rewrite 32 as 2 to the power of 5. So if I didn't know that, I can try around with my calculator. 2 to the 4th is 16, 2 to the 5th is 32, and I can find that out. So the left side isn't simplified this time. I have a power to an exponent, so I keep the base and multiply. 2 times x is 2x. So now I've got the same base on both sides, and I've simplified the exponents as much as possible. So my therefore statement this time is that 2x equals 5, but that's not solved yet. That's 2x, and I just want plain x. So what do I need to do to both sides? Divide both sides by 2. So x is 5 over 2. Okay, x is 5 over 2. All right, and E is also good. Step 1 is to get exponential by itself. So when you see one like this, and more often you'll see one like this in word problems when we get to those on Thursday, you want the exponential part, which is this part, by itself on one side. So your first step would be to divide both sides by -4, so that you just have the exponential part by itself. Okay? So you just have the 3 to the x now equals positive 9. Then you want to get a common base, so you see, can I write 9 as 3 to the something? Yes. So 9 can be written as 3 to the power of 2. So now I've got the same base on both sides, so the exponents have to be equal, and x then has to equal 2. Okay, this one, the exponent's a little bit more complicated. 7 to the power of x plus 3 equals 49. But we're still going to use the common bases. So I would check, can I write 49 as 7 to the something? Get my calculator out. Yes, 7 squared is 49, so I would do that first. Now that I have a common base on both sides, I can set the exponents equal to each other. So my therefore statement would be therefore x plus 3 equals 2. But that's not done because I don't have x by itself. In this case, I would subtract 3 on both sides. So x would end up being negative 1. All right, now we've got x on both sides. It is slowly getting more complex. The first thing you would do then, identify the bases. Is it possible to write 125 as 5 to the something? Yes, so I would do that first. So I'm picking out 125, and I want to write it as 5 to the power of something. 3. 5 to the 2 is 25, 5 to the 3 is 125. But that's still all being raised to the power of x plus 4. Okay, so now I've got to make sure every side's simplified and written as 5 to the something. So this side's simplified and written to 5 to the power of 2x. This side, what do you think this side would look like when I do that power of a power? Good, so you have to multiply the exponents, but when you do that, you have to use the distributive property. Good, so you would get 5 to the 3x plus 12. Now we have it 5 to the something equals 5 to the something else. So that's where you're ready for your therefore statement. If the bases are the same, therefore the exponents must be equal. So therefore, 2x has to equal 3x plus 12. The exponents must be equal. So now to get x by itself, I have to get all the x's together on one side. So I can subtract 3x on both sides. Which would give me negative 1x, or negative x, equals 12. But I need to know positive x, so I'm going to divide both sides by negative 1. So it turns out that x should be negative 12. So that's the solution of your exponential equation. All right, H is another example where you need a common smaller base. So I wouldn't do that right away because my first step would be to bring the 27 to the numerator. So it would be 27 to the negative 1. Once I've done that, now here's where I look and see, can I write 27 as 9 to the something? Well, 9 squared is already 81. So now I look for a common smaller base. So is there a common smaller base where I could write 9 as that to the something and 27? 3, yes. Okay, so I can rewrite 9 as 3 to the power of 2. That's still to the 6x. And I can rewrite 27 as 3 to the power of 3. And that's still to the negative 1. So then I have to use the power of power rule and keep the base and multiply the exponents on both sides. So I get 3 to the 12x equals 3 to the negative 3. So now I've got 3 to the something equals 3 to the something else. Therefore, 12x has to be negative 3. Divide both sides by 12. So that's negative 3/12, but that reduces. You divide top and bottom by 3, it reduces to negative 1/4. Okay, I is similar. I think no, those do I together. Similar, but it's a bit trickier with the negative exponent. And the x plus 5. So our first step would just be to bring this up. So it's going to be 8 to the x plus 5 to the negative 1, as we brought it up from the denominator. And then before I even worry about common bases or anything, I want to do this power to a power. So I have to multiply these exponents together. So you can use the distributive property like that. So you get 4 to the 2x minus 1 equals 8 to the negative x minus 5. You have to distribute that negative 1 through both pieces of the exponent. Okay? Now is where I would look and see, can I write 8 as 4 to the something? 4 squared is already 16. So now I'm looking for a common smaller base, which is 2. So I want to write each of those as 2 to the something. So now I'm going to do times. Okay, who was able to rewrite 4 as 2 to the something? Jack?
It's 2 to the power of 2, brackets, 2x minus 1.
Yep, and 8?
And then 8 is 2 to the power of 3.
Yep.
Brackets, negative x minus 1.
Excellent. Yep. Okay. But if you distribute, what should your next step look like, Jack?
It should be 2 to the power of 4x minus 2.
Yes.
Equals 2 to the power of negative 3x minus 15.
Minus 15, good. Be careful there. Okay. And then now we've got the bases are equal, so therefore statement would be therefore 4x minus 2 equals negative 3x minus 15. Now what?
Me?
Yeah, sure.
Oh, yeah. So you have to be 3x on both sides.
See, that's what I would do too. 7x minus 2 equals negative 15. Be careful of that negative.
And 2 on both sides.
Yep. So 7x equals negative 13.
And just back both sides.
Awesome. So after the therefore, it took us 3 more steps to get to the answer. And then make sure that fraction's in lowest terms with it. Good. So for today, that's kind of like the hardest one we would get to. Okay. All right, J is another. Any idea what we do for J first? Yeah.
Divide both sides by -5.
Yeah. Okay, we want to get the exponential part by itself. So if we do that, we're going to get our 27 to the power of x equals positive 9. And then we would look and see, can I write 9 as 27 to the something? 27 is already bigger than 9, so there has to be a common smaller base. Any ideas of what our common smaller base is? Jazz knows it is 3. So you want to try to write both sides as 3 to the something. Try to write both. Okay, does somebody think they've got 27 written as 3 to the something? 7. 3 to the power of 3, good. And that would still be to the power of x equals, and then 9 written as 3 to the something? 3 squared? Okay, so that should be your next step. So I rewrote 27 as 3 cubed, still to the x, and I rewrote 9 as 3 squared. Then my next step down, I'll have 3 to the 3x equals 3 squared. So now I've got base to exponent equals base to exponent. So I'm ready for my therefore. The bases are the same, the exponents have to be the same. And now I can divide both sides by 3. And we get x equal to 2/3. Okay, our base is a fraction. Our base is a fraction. So I have to rewrite 81 over 16 as 2/3 to the something. That's going to be my strategy. I'm going to rewrite this as 2/3 to the something. Okay? Both sides have to be 2/3 to the something. Do you guys see in your mind, or can you make the connection that the 2 and the 16 are related, and the 81 and the 3 are related if you look at bases? People see that? Could you ever do 2 to the power of something and get 81? Is that, you could try, but you wouldn't, right? 2 to the power of something is always going to be even. So does anyone have an idea what my first step would be then if I want to rewrite this side as 2/3 to the something eventually? Seth? Yes, flip it. So I'm going to do 2/3 to the x equals 16 over 81 to the -1. So now there's got to be a way to rewrite 16 over 81 as 2/3 to the something. And then that'll be to the -1. Any ideas how we go about finding out this exponent that would go right there? So when I raise it to the power, 2 to the something has to give me 16, and 3 to that same thing has to give me 81.
It's 4.
It's 4. And how did you go about figuring that out?
I knew 1 and 3 for the next option.
Okay, so you tried 2 to the 3rd, that didn't give me 16, that gave me 8. 2 to the 4th gave me 16, and I'll check and make sure 3 to the 4th gives me 81. Okay, good. All right, so that is correct. But the 2 sets of brackets, make sure you use them, okay? Because now we're going to use our power of a power rule. So we keep our base 2/3 and multiply our exponents. 4 times -1 is -4. So now the base on both sides is 2/3. Base to exponent equals base to exponent. Therefore, x equals -4. Okay? And our last one. Also a fraction. So my strategy is I'm going to want to write this side as 5/3 to the something. But does 5 go with 125 and 3 with 27? Yes, so I don't have to flip this time. Okay? I wouldn't have to flip because I can write 125 as 5 to the something. So that would be my next step then, would be to see what number works if I want to write this as 5/3 to some exponent. What would that exponent be? 3. 5 to the third is 125. 3 to the third is 27. Okay. So now I've got both sides are a base to an exponent. So therefore, x minus 4 equals 3. And I want to get x by itself, so I'm going to add 4 to both sides. So x is going to equal 7. Okay? So that is solving exponential equations. Awesome.